Since its initial discovery, Saturn has engaged scientists in unraveling its mysteries. One of the most captivating features of this planet is its remarkable ring-like structure. Notable figures such as Galileo, Huygens, and Cassini, along with everyday enthusiasts like amateur astronomers, have long been fascinated by the allure of the Lord of the Rings. With exploration missions dispatched to Saturn like Voyager and Cassini, we now possess a comprehensive understanding of its substructures, encompassing its moons and rings. While we've grown accustomed to beholding Saturn's majestic display of rings, what if I told you that they will soon vanish from our sight? Join me in watching this video to understand how this can happen and when it's expected to occur. Saturn to lose its rings very soon. Don't miss it. The Lord of the Rings. Saturn, visible to the naked eye since prehistoric times, intrigued ancient civilizations. The Assyrians around 700 BCE described it as a sparkle in the night, calling it the Star of Ninib. Later in 400 BCE, ancient Greek astronomers honored the god of agriculture, Kronos, naming the wandering star Saturn. The Romans later adopted this name. Then in 1610, Galileo Galilei made a groundbreaking observation. His telescope revealed Saturn's mysterious rings, initially confusing. They looked like arms. Galileo even speculated about large moons on either side of Saturn, only to realize later that he was viewing the rings edge-on. Galileo's telescope was a very rudimental one. Saturn would appear like a fuzzy object in the sky. He even attempted to draw what he saw. Here's his drawing. In 1659, Christian Huygens, with improved telescope optics, deduced that Saturn's arms were in fact a ring system. Huygens also discovered Saturn's moon Titan, and the probe exploring Titan bears his name. In 1675, Jean-Dominique Cassini discovered major moons in the famous Cassini division. Over the centuries, more discoveries unfolded. In the 19th century, J.E. Keeler revealed that Saturn's ring system is not a uniform sheet, but comprises small particles. Saturn, with its butterscotch-colored appearance, is the sixth planet from the Sun, the second largest in the solar system. Fast forward to today, 4 robotic spacecraft, starting with Pioneer 11 in 1979, have ventured there. In 1973, Pioneer set the stage for space exploration. Launching on April 6th, it arrived at Saturn on September 1st, 1979. This amazing probe provided valuable data about Saturn's atmosphere and magnetic field, and even discovered 2 new moons. Some years later, the Voyager missions, with Voyager 1 launching on September 5, 1977, and Voyager 2 on August 20, 1977, conducted detailed studies of Saturn's atmosphere, rings, and moons. Voyager 1 revealed the intricate structure of Saturn's rings, while Voyager 2 provided more insights into its moons. Enter Cassini-Huygens in 1997. This probe was a game-changer. It arrived at Saturn on July 1, 2004, and spent over 13 years orbiting the planet, studying its rings and moons. The Huygens lander, carried by Cassini, even descended to Titan, Saturn's largest moon, providing valuable insights into its chemical composition and formation. Cassini's grand finale in 2017 marked the intentional end of its mission, diving into the planet's atmosphere. This phase provided unprecedented data on the planet's atmosphere and gravitational field, rings, and moons. And this is exactly what we are going to talk about. Join us in the next part as we delve deeper into the mysteries of Saturn's rings, its diverse moons, and the ongoing research that continues to shape our knowledge. Once the Earth had a ring. Known as the Lord of the Rings due to its remarkable ring system, Saturn has mesmerized astronomers for ages with its celestial beauty. This gas giant stands out with its elegant rings, leaving Earth envious of its ringless state. The Roche limit, a crucial concept in understanding reformation, is also responsible for this. It is the minimum distance at which tidal forces prevent celestial bodies from coalescing. Saturn's rings are comfortably within its Roche limit, allowing them to exist without merging into the planet. Had an asteroid or moon passed this limit, it would start to break into pieces of various shapes and dimensions, which in the end would start orbiting the gas giant. Additionally, Saturn is home to a multitude of moons, each exerting a distant influence on its ring system. Previously, it was believed that the gravitational interactions between these moons and drifting debris contributed to the formation and maintenance of the rings. However, recent research suggests that these moons may actually lead to the gradual loss of the rings due to their dynamic effects. For instance, the James Webb Space Telescope's latest discovery unveils a possible occurrence of this phenomenon with Uranus. For a more comprehensive understanding, watch the video provided in the link description. Just like Uranus, Saturn is allegedly expected to part ways with a significant portion of its rings in the near future, but for a whole different reason. To discover the exact cause behind this impending event, continue watching the video. Hey, before moving on, be sure to like or dislike the video so that we can improve it for you, the viewer. Plus, don't forget to subscribe to our channel by making sure to hit the notification bell so you don't miss any of our daily videos. It is important to note that Earth's Roche limit is much closer to the planet compared to Saturn's. As a result, asteroids can make multiple close approaches to Earth without being destroyed by the laws of physics. In addition, the tidal forces exerted on Earth by the Moon, the Sun, and other planets have been shown to be unfavorable for the formation and stability of extensive ring systems. Furthermore, for something to be destroyed at the Roche limit, there needs to be available material. It is possible that Earth did not have enough material during its formation to develop a ring. The planet did not grow sufficiently massive to attract debris that could form a stable ring. It's also worth noting that most of Saturn's rings consist of ice, which is not stable at closer distances to the Sun. Nonetheless, scientists know that Earth once possessed a ring, possibly originating from its own planetary material, thought to have transpired from a colossal celestial body colliding with our planet in its formative stages. As a consequence of this collision, Earth temporarily boasted a ring-like structure, which eventually amalgamated into the celestial body we now identify as the Moon. Anyhow, while Saturn proudly displays its rings, planets like Earth remain ringless. This is the beauty of the universe we live in. Each celestial body showcases the unique features dictated by its composition, distance from the Sun, and gravitational dynamics. What Cassini found out about Saturn's rings. As I told you before, Cassini's mission has been the real game changer when it comes to the study of Saturn's rings. Its journey uncovered extraordinary ring-moon interactions, allowing us to witness the dance of celestial bodies. The spacecraft observed the lowest ring temperature ever recorded at Saturn, providing a glimpse into the chilling beauty of the ring giant. A groundbreaking revelation emerged as Cassini discovered that the moon Enceladus was the source of the so-called Saturn's E-ring. This moon, venting icy particles into space, added a dynamic layer to the ring system, showcasing the interconnected beauty of the Saturnian system. NASA's probe meticulously studied the size and distribution of ring particles. By observing how the light of distant stars changes when passing through the rings and how our sun's light reflects off them, the spacecraft unraveled the mysteries of these icy chunks ranging from smaller than a grain of sand to the size of the Rocky Mountains. The rings, approximately 30 feet thick and composed of billions if not trillions of water-ice particles, became the canvas for Cassini's exploration. The spacecraft witnessed some of Saturn's moons stealing and contributing particles to the rings, showcasing the intricate dynamics at play. The Cassini mission showcased phenomena like propellers, several thousand miles long, created by the gravitational influence of moonlets. These lumps of ring material, smaller than moons but larger than individual particles, launched surrounding ring particles, unveiling captivating features. The spacecraft's instruments captured peculiar features resembling spokes, finger-like radial formations within Saturn's rings. These spokes, thought to be tiny ice particles lifted above the surface by electrostatic charge, introduced an element of mystery and dynamic beauty to the majestic ring giant. Similar to Earth, Saturn experiences seasons, but with a remarkable duration of around 7 to 8 Earth years per season. Can you fathom the challenges of enduring a 7-year winter? Fortunately, spring eventually graces the planet. The equinox marks the transition from winter to spring, a day where day and night share equal duration. Equinox events offered Cassini a unique perspective on Saturn's rings, unveiling countless icy clumps casting colossal shadows. Monitoring temperature changes during equinox provided valuable insights into the composition and characteristics of ring particles. From spokes and clumps to propellers, moonlets, rings, birthing moons, and moons forming rings, Cassini's revelations have woven intricate layers into the captivating tale of Saturn's rings. As we marvel at these celestial wonders, one can only contemplate how Galileo himself might have responded to the mesmerizing views now accessible to us all, courtesy of Cassini. The disappearing rings. Saturn's rings will seemingly disappear from view in 2025, a phenomenon caused by the planet's rotation on an axis. Saturn won't actually lose its rings in 2025, but they will go edge-on, meaning they will be essentially invisible to Earthlings, NASA confirmed to CBS News. The rings will only be slightly visible in the months before and after they go edge-on. How's that even possible, you might ask? Well, it is a matter of perspective. Because the planet rotates on an axis tilted by 26.7 degrees, the view of its rings from Earth changes with time. Vahi Perumian, professor of physics and astronomy at the University of Southern California, told CBS News via email. Every 13 to 15 years, Earth sees Saturn's rings edge-on, meaning they reflect very little light and are very difficult to see, making them essentially invisible. The rings last went edge-on in 2009, and they will be precisely edge-on March 23, 2025. It also happened in 1995. Here's how they appeared back then. Both images were captured using Hubble's Wide-Field Planetary Camera 2. The upper image was taken in visible light, while the lower image presents Saturn's disk differently. This variation is due to the use of a narrowband filter, selectively allowing light unaffected by methane gas absorption in Saturn's atmosphere to pass through. Despite Saturn being roughly 900 million miles away, Hubble could discern details as small as 450 miles across. This type of observation was employed to ascertain the timing of the ring plane crossing and the thickness of the primary rings, as well as to explore potential undiscovered satellites. The beautiful thing is that, years later, Cassini directly measured these parameters by physically approaching the target. In any case, don't worry. Going edge-on in 2025, the rings will become visible again just a few months later. That's all for this video. Thanks for watching. Are you ready to see Saturn's rings disappear? Let us know in the comments below. We'll see you next time on the channel.